let's begin. Okay, version A. Do I need to give you the correct answer for the true and false?
Yeah.
Well,
Yeah,
sure.
What's the first one? I put true and wrong.
I put both of those on.
You got different tests. Can't fool me. Well, you can, but none of that. Read through those, I'm sure you'll figure it out.
Is that stapler coming around or what?
Yeah.
Oh.
Is that stapler coming around? Or is it hung up somewhere? Who has the stapler?
That's fair. How long there's no true and false at the next test? That's what I got.
Is that right?
Yeah, lost all my marks.
Well, you know what? I don't really like true and false. It's not really a particularly good
Because I'm not on one
assessment strategy. This thing did.
Technically it does.
But
It worked for me.
But I know that universities will be using stuff like that still, and so I'm trying to get you used to it without being your entire test. What the heck's going on here? I charged it up. Do it this way. Okay. Multiple choice, version A. Correct answers are A. Easy to mark. Version A, multiple choice, A. Okay? It's straightforward F equals MA problems. If you can't solve those, you need to come and see me. Those are easy. I'm not trying to make you feel bad. I'm trying to get you to learn how to do them. They are easy. It is not hard. If you have version B, the answers are C, A, and then D. Okay? C, A, and D. Flip the page. Version A, 10 and 11. D and B, as in dog and bone. Version B, answers are C and D, as in I don't know.
Can't think of a word with C and D.
No, I can't. Crazy.
Diana.
Okay, there you go. Number 12, complete Newton's third law. When one body exerts a force on another, the second body, I was looking for two words, exerts an equal and opposite, but you must say force.
Yeah, I think it's force and
Equal and opposite force. Don't be lazy and just write equal and opposite. Your laziness is costing you. Do it right. Okay, when we get to the next page, all the problems are the same to make it a little bit easier. Here we go. Okay. I don't know how many times I've showed you guys problems like this. You have to believe me when I say there will be a question like this on the test, and you should do 5 of them to learn how to do it. Maybe next unit you'll figure that out, because I can tell some of you do not practice enough. This is identical to questions that we did in practice. 30.8 kilogram sleds being pulled across a frozen river. Boy 1 is pulling straight west with 68 newtons. Boy 2 is pulling straight north with 66. The force of friction is 10.1. What's the resulting acceleration? I want a picture. Not a belly itcher. 66 and 68. This is the overall force. Can you just add 68 and 66? No, I've shown you this 100 times. You must add them by Pythagoras. You must do that. If you don't have that on your cheat sheet, get it on there, you guys. I know that I did these with you. Then what? Subtract friction. The net force is the applied force plus the friction force. 94.8. Subtract or add negative friction. 10.1. 84.7. Amanda, you need to watch. Listen. Now we're going to go. F net equals MA. 84.7. What's the mass? 30.8. You get an acceleration of 2.75. And do you have to include the angle? Yes! How do you know you have to include the angle? Because every example that I showed you like this had the angle. And it says in the question, north and west. If it has directions like that, you need them in the answer. So inverse tan, 66 over 68. West 44 north, and if you had it upside down, then it would be north 46 west. 1, 2, 3, 4, 5. Will that question appear on the exam?
Yeah. Nope.
Good chance. I can't say for sure. I have to sort of pick and choose. I can't give you every problem example on the exam simply because of time. But is that a pretty good one?
How long does it usually take to write?
I've had kids write for 3 solid hours.
Holy, what's 66 over
68. It's been pared down over the years. You do? A full page. Full page, Will.
I just give myself space.
Yeah, I noticed. I'm not making a big deal of it because, yeah, I know.
Can put it out.
I know. I look at it and I go, yeah, well.
I don't want. Maybe you should. No, because I can't read when it's like super. You get good spectacles.
Spectacles.
That's 2020. 21 to 21, actually.
Next question is the free body diagram. I think everyone got it right. Normal force, weight force, friction, giant applied force. Peter, was your number 15? I can see there's still lots of people that still subscribe to the, I'm going to answer a question like this with both yes and no and hope that he gives me the full marks.
Yes.
Because I had several people that basically said yes, but then explained no, so that they could argue it later. I don't know if that's your intention or not, but it's not going to work. Pick a side and defend it.
It did for me.
I said it depends if it says.
So what's the correct answer?
The correct answer is no. She cannot assume it is rest. You can't say yes, she can assume it's at rest, and then go on and say, but it could also be moving.
But it I said it
Wait, but then it's not yes. The answer is no. I know that, but you can't say yes, she assumes it must be at rest, but it could also be moving.
Yeah.
That's both. You're saying both. You can't say it must be at rest.
No.
It must be at rest. You have to say it could be at rest, or it could be moving. You can't say it must.
Assume.
She could, but she would be wrong.
You should have gone like question says
I can't hear you, Nick. No. Wow, that's right. She can't assume anything. That's right. You can't say yes. You must say no. What did you say after that, Peter?
Oh, I did. I said, yeah, if the option is like this, it wouldn't be like this.
But did you say yes, she can assume it's at rest?
I didn't say that. I said, oh, I'm gonna have to.
You can't say yes. You must say no. She cannot assume it's at rest. It could be at rest or it could be in motion. And it's really subjective how I mark it, you guys. So if you're, be careful what you're writing. Read it back to yourself. Don't be lazy. Write a full sentence and explain yourself. Having said that, don't go on and 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 on, because there's a good chance if you do that, you're going to make some logical error somewhere, or it's not going to make any sense. Flip the page. Randy is pulling his sister on the toboggan. Okay, did you know there was going to be a question like this?
Yep.
Yes, I told you that. These problems, you guys, should be automatic. They really should. There is no surprises anymore. No surprises. All you have to do is know how to do them. And if you don't know how to do them, come and see me. Waiting till after the test is not a good strategy. Okay, you guys need to be a little quieter.
Mr. Bennett, what year did Christopher Columbus come to Canada?
Canada?
Yeah.
I don't think he ever came to Canada.
Okay, well, North America, whatever.
1492?
Oh my God.
I think he landed like in Jamaica or someplace, I think, first.
Well, that's not North. Okay, when did he come to like?
I don't know, man. I'm a little weak on my Columbus history. But I do know the horizontal component in this case. Okay, guys, I want to get through this. Lane, I need to get through this. 97 cos 12. 94.9. Once you've got the horizontal component, find the net force. And again, I've done these already, you guys, for you. FA plus FF. 94.9 minus, what's the friction force? 12. 82.9, and then you're going to go. Okay, Lane, seriously. Stop. I'm trying to teach you this. Stop. 82.9, the mass. 47. Thanks, Mr. Zalsher. Have you got any more of those power ones? I seem to have in my... Alright, so you get an acceleration of 1.76. Okay, enough with Christopher Columbus, you guys. As much as I don't want to kill your creativity,
Well, you like to tell me.
I know, and I'm done. Do I need an angle here?
Yeah.
They always need angles.
Is there east or west or north or south mentioned in the question? No. It's moving to the right, so the fact that it's positive is good enough.
Okay, I did exactly what you did, and the only thing we 3.5 marks.
Exactly?
Yeah.
Exactly.
Is it okay that I use 85, not 2.9?
No, it's 82.9.
But you still marked it right, actually.
Well, then why are you even mentioning this to me?
That's like, what did I do wrong?
Yeah, 1.8.
Okay. Physics student tells the class, here's another good example. Too much coffee or something other day. Here's another good example of you have to come up with a position and defend it, and do not try to do both so that in hopes that you can argue for marks. It's not going to work. Pick a position and defend it. A physics student tells a classmate that when a bullet is fired from a gun, it accelerates after it leaves the barrel until it hits something or falls to the ground. Is this true or not? Use Newton's laws to explain. Now, you could actually say true or false depending on what you said. It is true that it accelerates because it's accelerating actually vertically and speeding up as it falls to the ground, as it goes sideways. You could say that. You could say true, it slows down because of air resistance, and slowing down is a type of acceleration known as negative acceleration. I would accept that. Or if you said, no, this is not true, the object continues in motion forever and ever and ever, but it doesn't speed up once it leaves the barrel, does it? Because once it leaves the barrel, is there a force on it anymore?
Nope.
No. So I will take yes or no depending on which part of the situation you're describing. Okay, and I actually was pretty pleased. Most people did a pretty good job of describing that. Okay, last one, and then we will move on. Would you agree that number 18 is kind of a review from this unit and the last unit?
Yeah.
Okay, so again, these are the kind of questions you can expect to see on the exam because they cover lots of different things. Drag ratio produces a force of 4,000 newtons. Car has a mass of 538. Friction is 105. What's the acceleration? And how far will it have moved? So, first step, F net is equal to the applied force plus the friction force. The applied force is 4,000. Subtract 105. 38.95. You always add the negative, right? Or like, I shouldn't say that because sometimes you don't, but do it, you guys. You can do this. If you do the practice problems, you will get these. If you choose to not do them, you won't get them. You gotta practice it. 38.95, the mass. 538, solve for the acceleration. 7.24 meters per second squared. Okay, that's the dynamics part, and then it says how far will it have moved. Now you're going to go A equals delta V over delta T, acceleration of 7.24 change in velocity. Time is 3 seconds, so the velocity changes by 21.72. Is that the final velocity? It is. How come? Because the initial is 0.
Well, I
Right.
don't know.
But can you use that in determining the distance? No, you must use average. Remember, plain old V doesn't exist. It's VI, VF, delta V, V bar. There is no such thing as just V.
Somehow I got that.
Doesn't exist.
I put 21.7. I'm done.
So now you're going to go 0 plus 21.72 divided by 2, 10.9. And now V bar equals D over T. Whoops, 10.9. And the time was 3 seconds, giving you a displacement of 32.5 meters. Okay. Again, I was pretty pleased with the overall results. There are some people that just need to practice more. You got to take your books home and you got to practice. It's as simple as that, you guys. Okay? As simple as that. Okay, let's stop that.